Hello students, in this video we're going to consider a set H, which is the set of points that constitute this line. That set will be called H. It's defined by this line, 4x minus 3y equals 0. We're going to determine whether or not that set of points is a subspace of the vector space V, where V is R2, that is the Cartesian plane. That's your xy coordinate system here. So is this line a subspace of this space here, the Cartesian plane? So the three things we're going to test here are, is the zero vector in the space H? So is the point 0, 0 on this line? If we take a vector u from the set and a vector v from the set, so those are 2 points that actually any 2 points that are on this line, if you add them together, add those 2 points, do you get something that's back on this line again? That's what this question is asking. So remember, if u is in the set H and v is in the set H, is u plus h in the set H? And then we'll consider if you take some scalar from the field, that is from R, from the real numbers, and you multiply it by a vector. So if you take some number and you multiply it by a point on this line, will you still be on this line again? Okay. So those are the three things we have to test. So is is 0 in the set? Is the set closed under vector addition? That means if you take u from the set and v from the set, is u plus v in the set? And is the set closed under scalar multiplication? So if you take some number and multiply it by a vector, is that multiplication still in the set? Okay, let's proceed. So the zero vector looks like the point 0, 0, and we want to know, is that in H? If u is in H, then let u be the vector x1, y1, where, now remember, for it to be in H, it has to be on this line, so it has to satisfy this equation. If v is in H, then v is equal to x2, y2. I just use those coordinates, so that's the point x2, y2, and that coordinate has to satisfy the line, so 4x minus 3y has to be equal to 0. And then if k is in R2, then if k is in R, I should make that an R, that's not R2, okay, then is k times the vector u, x1, y1, is that also in the space? All right, let's proceed. All right, so first we take the point 0, 0, so that's x is 0, y is 0. We plug it into this is our test, 4x minus 3y. Is that going to be 0? Well, 4 times 0 minus 3 times 0 is 0. 0 is equal to 0. So check this 0 is in the set. All right, now we proceed. U plus v is x1 plus x2 in the first coordinate, y1 plus y2 in the second coordinate. So we just added these two vectors. And then we test this point and see if it's in the space. So we take 4 times x1 plus y plus x2 minus 3 times y1 plus y2, because this is 4x minus 3y. We see, is that going to be equal to 0? Well, I distribute the 4, and then I distribute the minus 3, and then I just see if the sum of those two things is equal to 0. So I have 4x1 minus 3y1 plus 4x2 minus 3y2, and is that going to be equal to 0? Well, 4x minus 3y is equal to 0. That's up here. That's our test. So 4x1 minus 3y1 is equal to 0 because, remember, x1, y1 is in the space, right? 4x1 minus 3y1 is equal to 0. 4x2 minus 3y2 is also equal to 0, and 0 plus 0 is equal to 0. So check, u plus v is in the set. And then finally, I take the k and I factor it out, and then sure enough, 4x1 minus 3y1 is equal to 0. So k times 0 is equal to 0, so 0 is equal to 0. So that means that K U is in the set. So let's see here. 0 is in the set. The set is what we call closed under vector addition. That means if U is in a set and V is in a set, then U plus V is in the set. It is closed under scalar multiplication. So the set is closed under scalar multiplication. That means if U is in the set H, then K times U is in the set H, where K is just some number. And that means that H is a subspace of the vector space V. Yes, so this line here is a subspace of the space R2. All right, good luck.